Hello everyone. Today let's talk about direct and indirect band gap of semiconductors. I'm Nikhil Raiprolu from International Institute of Information Technology, Hyderabad. Direct and indirect band gap of semiconductors. The band gap represents the minimum energy difference between the top of the valence band and the bottom of the conduction band. However, the top of the valence band and the bottom of the conduction band are not generally at the same value of the electron momentum. In a direct band gap semiconductor, the top of the valence band and the bottom of the conduction band occur at the same value of momentum. As shown in this diagram, here you could see that the top of the top of the valence band and bottom of the conduction band are at the same momentum. So here momentum is x-axis and the energy is represented on the y-axis. Here the gap between these two points is called as energy gap. Whereas going with an indirect band gap or an indirect band gap semiconductor, the maximum energy of the valence band occurs at a different value of the momentum to the minimum of the conduction band energy. If we look at this graph of indirect band gap semiconductors, here the minimum of the conduction band and the maximum of the valence band are not at the same point of the on the x-axis or the k vector. Here the energy gap is represented in the vertical direction, and if we also look at this, we can mention a momentum gap over here. This momentum gap could be seen on the seen as the distance on the x-axis. So here, k is also the k which we are representing on the x-axis is in short called as momentum or as k vector or crystal momentum. In direct band, since crystal momentum of electrons and holes is the same in conduction and valence band, an electron can directly emit a photon while jumping into a hole, since both energy and momentum are conserved. Whereas in indirect gap or indirect band gap semiconductor, a photon can be emitted because the electron, a photon